Welcome to Philosophy of Value Workshops number 3B of Series 10. The question for today is, how are causality, Leibniz and Hume's fork relevant to science and consciousness? In these workshops I'm proposing that subjectivity as consciousness is a starting point for a philosophy of life. That is, a philosophy of life based on an aspect of mind or consciousness that we call value, and that value provides a principle of the will to value leading to a certain sufficiency of value. I give explanations and make arguments for this claim elsewhere. On the question of moral value, David Hume is well known for his critical is-ought distinction, as well as his critique of the idea of the self and of the unity of the self. Yet he also had great influence on science with his idea known as Hume's fork. This influenced our understanding of causality and deductive or inductive methodologies. And this influence is so great that it leads to another way of understanding the relations between objects and the relations between objects and consciousness. This has the effect of offering a solution to what David Chalmers called the hard problem, that Paul Davies described as arguably the hardest problem facing science today. But to begin, we can define Hume's fork as a radical distinction between relations of ideas and matters of fact. Relations of ideas are only known through reason and definition, like a triangle has three sides. And matters of fact are about the material world and require empirical evidence. Hume's fork between ideas and facts also leads to another distinction between a priori and a posteriori judgments. A priori judgments are made without reference to facts outside the context of that judgment, like 2 plus 2 equals 4. A posteriori judgments are contingent and are based on empirical observations and evidence. These include judgments like gravity exists and the earth circles the sun. For a few minutes I will be making several such distinctions. These are needed to understand modern philosophy, but not if you are only here for the general conclusions. I first need to note that empirical and a posteriori judgments can also be called synthetic. And one distinction that we'll be referring to later is the analytic synthetic distinction. Analytic statements are similar to Hume's relations of ideas. They depend on the meaning of words, not on empirical facts. But the a priori, a posteriori or synthetic distinction has implications for science that we will discuss shortly. Yet it also has interesting implications for theories of mind, ethics and value. That is, Descartes and Kant, for example, claim the existence of synthetic a priori knowledge about the world of actual existences through the mind or reason alone. Descartes claims that I think, therefore I am. Kant claims the validity of a universal ethic. Both these claims, and especially their further theological and ethical inferences, are highly contentious. But I also claim that the will to value is a synthetic a priori, because not to value value is contradictory. I mention this for clarification and because it's related to why I'm discussing this topic at all. And also, in my view, for Hume's fork between ideas and facts also implies a further distinction or relation. That is, a relation with consciousness that Hume had to omit given his modular theory of mind. Yet this distinction and relation is exemplified in Karl Popper's idea of three worlds or realms. In this view there are three species of existence: matter, mind and its abstract products. Different versions are held by Roger Penrose, Robert Hubert Dreyfus and Merleau-Ponty. But these views about matter, mind or consciousness, and thought or abstraction are just part of my introduction. I note them in order to indicate the significance of Hume's fork to questions of consciousness and value, and their relation to thought and cognition that I haven't had yet time to explain here. The ostensible topic today is, however, the relation of Hume's fork to science as well as to consciousness. This can be discussed through both the concept of causality and the deductive-inductive distinction. On the inductive method, many observations are made in working towards general principles. The deductive method is the reverse, working from general principles to particulars. In practice, some combination of deductive and inductive methods are usually used. That is, except in logic and mathematics, where we can nearly always work from general first principles. So the nature of the subject matter should determine the kind of method that should be used. But the physicist David Deutsch rashly dismisses induction and empiricism in favour of a form of creative deduction. Based on the limitations of induction, he writes, since induction is false, empiricism must be as well. Conversely, Karl Popper gives us a falsifiability criterion that genuine science must be falsifiable. And Whitehead also reminds us that every philosophy and metaphysic will suffer a deposition. Hume similarly holds that scientific laws are contingent because they are discovered empirically and can be wrong. In this sense, scientific laws aren't immutable laws at all, but are provisional principles. Hume's point is that such principles are produced from numerous observations and experiments, and it doesn't matter how many observations are made, they are never complete or absolute. For example, prior to the Hubble telescope, it was thought that the expansion of the universe was slowing. Now, with the discovery of dark matter, we find that this expansion is speeding up. But this was a totally unexpected discovery, contrary to scientific orthodoxy. Moreover, the universe is taken to be held together by the forces of gravity, and it certainly is. But gravity is the description we have given to things that happen in a certain way for an uncountable number of times. We understand a lot about gravity, but we don't have a complete theory of gravity and never could. So if dark matter overtakes ordinary matter, gravity could end and the universe could fly apart. Not that this is probable or even remotely possible. The point is that we don't know and can't be certain. We can't be certain because empirical knowledge is obtained through observation and is contingent. And as A.J. Ayer and others agree, certainty is only found in the necessary relations of logic and mathematics. In his work on causality, the cement of the universe, John Mackie discusses Hume at length. Mackie disputes a recent critique of Hume that he confuses logic with psychology. But he does say that Hume's resort to psychology was premature. Mackie explains that Hume looked for a psychological explanation of a very puzzling idea of a necessary connection without having properly shown that kind of necessity in the mind really was the key element in our concept of causation, unquote. That is, the concept of causality is more complex and abstruse than we think. Yet before continuing, we should briefly discuss whether Hume's fork was anticipated by Leibniz's distinction. Leibniz made a distinction between truths of reason and truths of fact, very similar to Hume's distinction. That is, between truths which are necessary and can be known a priori and those which are contingent. But William Valicella says that they are not the same because, since for Leibniz every truth is analytic, while for Hume some truths are analytic and some are not. The two distinctions cannot be the same. And he also says that contingent means different things for Leibniz and Hume. Contingency in Hume cuts deeper. Not only is existence contingent, it is also contingent in its properties, unquote. But this seems only to be a technical point. And in my view, Hume and Leibniz were still making the same crucial distinction between empirical facts and reason, even though the differences were greater regarding the concept of causality, as we will see shortly. And this difference seems explicable because Hume is an empiricist, whereas Leibniz is a rationalist. So Leibniz and Hume had different theories of causality. Leibniz believed in multiple types of causes, whereas Hume believed that all causes are of the same kind and are based on experience, not reason. And because for Hume ideas of causation come from experience, they are based on constant conjunctions of cause and effect. This results in Humeans talking about constant conjunctions rather than cause and effect. In my view, Hume proposed a subjectivist view of causality that was both chronologically and philosophically more advanced than Leibniz's objectivist and rationalist conceptions of causality. One difference, though, is that Hume held that we infer the effect of an event based on our past experiences, whereas Leibniz held on to a more metaphysical foundation, and that this foundation entailed three efficient, final, and formal kinds of causes. We can briefly define these three kinds of causes in order to contrast Hume and Leibniz. Leibniz's concept of efficient cause is most like our ordinary idea of causality as the active causes that produce change. For example, an engineer is the efficient cause of a machine that he designs and put together. And Leibniz believed that efficient causes were largely at work in the scientific revolution. In Leibniz's view, final causes explain the reasons why something exists or changes. For example, the final cause of an acorn is to become a fully grown tree. This view is quite metaphysical or mystical, yet final causes played a crucial role in his philosophy. Yet Leibniz's formal causes are perceptions that determine the content of a substance's future states. This sounds strange, but Leibniz speaks of perceptual states as unfolding spontaneously within entities, and that there is a purpose or end guiding the unfolding of perceptions in each substance. This also seems to imply the very contentious idea of reverse causation in time. So on the above points, we can see that Leibniz's distinction is based on metaphysics and rationality, whereas Hume's fork is based on empiricism and certain epistemological limitations. Yet they are both making the same distinction between empirical facts and reason. And for my purposes, I don't need to know any more about Leibniz's theory of causation, except we can note that he took the terminology of efficient and final causes from Aristotle, and that he holds that both God and created substances are causally active in substance changes. But as previously seen, both Aristotle and Aquinas believe that natural objects can be defined by their purposes, that is, illegitimately, in a way that assigns purpose to natural objects independently of human attribution. And Leibniz makes the same mistake, as well as proposing esoteric intercausal relations that are incompatible with modern science or philosophy. A further understanding of Leibniz thought can be drawn from his work, the Monadology. Monads are infinite in number and are the elementary particles or simplest units that make up the universe. But G.E. Moore called Leibniz's multiplicity of monadic entities or categories an ontological slum. Yet, to be fair, Leibniz's principle of sufficient reason was taken up and taken further by Schopenhauer and had been widely used by many philosophers to great effect. It is the principle that everything must have a sufficient reason, cause or ground for existing. Yet after Leibniz, Hume's theory of causality seems very down to earth, but it is still revolutionary. It is revolutionary in its distinction between empirical facts and reason that he partly shares with Leibniz. And it is also revolutionary in how Hume gives causality a psychological and subjectivist foundation. In his own words, Hume tells us that relations of ideas can be discovered purely by thinking, with no need to attend to anything that actually exists anywhere in the universe. But matters of fact are not established in the same way, and we cannot have such strong grounds for thinking them true. And the contrary of every matter of fact is still possible because it doesn't imply a contradiction." Unquote. As noted, this promotes an inductive method of moving from particular observations to general principles. Conversely, the deductive method moves from general principles to particular facts about the world. We should consider which of these methods are suitable for different subject matters. We can say that the inductive method moves through its subject matter in a process of elimination and selection. It might then be typically applied to matters of perplexity and confusion that we try to grasp in the human affairs. It thereby finds a natural affinity with questions of life and human lives. Conversely, logic and mathematics adopt a deductive model and work from general a priori first principles. Logic, for example, is determined by the self-evident and a priori truths of Aristotle's 4 basic principles of logic. David Hilbert described mathematics as avoidance of contradiction and is therefore a self-validating a priori. Mathematics and logic are a priori systems, but they can't establish principles for systems of physics or ethics. It's accepted that physics isn't an a priori system, but is an a posteriori system of contingent observations. So physics is a deductive system that attempts to construct general principles of understanding. Within the human sphere, a deductive, synthetic, a priori principle might be Descartes' "I think, therefore I am." Yet in a slight digression, I would again claim that Descartes' "I think, therefore I am" and the will to value is a synthetic a priori because the alternative is contradictory and self-negating. But in such applications, we have to question the use of logical terms to describe human reality, as well as question whether logic and rationality are the correct criteria to apply to human issues, and which kind of logic to model rationality on. Is it the propositional, symbolic, or modal logic? That is, the conditional, modal logic of if this, then that, or deontic logic of ought. There is also temporal logic of always, or epistemic logic of it is known that. My point is that the principle of excluded middle might not only be misapplied to physical and conscious items, but that it represents one kind of logic, and it is one kind of thinking that needs to be carefully applied. And there are also known challenges to logic and rationality, like ambiguity and vagueness. We should also mention the problem of logical tautology, that nothing can be added to or derived from a logical process that is not already in its premises. There is also the problem whether logical propositions, much less symbolic logic, can convey or contain the meaning of a rich human discourse. But we need to get back to the question of how these issues and the inductive method have consequences for science. Very few, like David Deutsch or even Plato, dismiss induction completely in favour of deduction. In practice, science uses both deductive and inductive reasoning depending upon the stage of the scientific process. For example, in the 17th and 18th century, science was often a matter of listing and categorizing observations. This inductive reasoning was often used to form initial hypotheses based on observations. Yet deductive reasoning can be used to test those hypotheses with specific experiments. In this sense, science takes a bottom-up approach with induction and a top-down approach with deduction. But due to Hume's empiricism and the possible failure of Leibniz's metaphysics, scientific principles are provisional. The provisional nature of inductively derived principles can be illustrated with the experience of colour. For example, on the inverted spectrum hypothesis, we understand that people see colours arrayed in different ways. And psychological studies show that different creatures had different colour perceptions. The conclusion is that there is no colour in the world because it's projected onto the world by our optical faculties. Yet different creatures with different subjective colour perceptions are able to operate quite well in the world. And this illustrates how pragmatic but subjective conceptions could also work for science. This conclusion is reinforced by our understanding that science isn't an absolute, but is a process of development. To show this, Aristotelian science gave way to Newton, who was overtaken by quantum science. And it's widely agreed that this process of development has not and might never finish. The outcome is that science is an inductive process, the principles of which, like causality, are not definitive. Mackie describes this uncertainty in that it's possible that some or even all of the situations and sequences that we recognize as causal should have features which we have not fully recognized, or perhaps which we have not discovered at all, and which therefore are not built into the meaning of a causal language. Unquote. That is, when we observe two events that are supposedly cause and effect, we don't really know what is going on. We see one thing happening and then another, but like gravity once was, that event is a black box. An example of the standard concept of causality being inadequate is the modern idea of complex causal fields. That is, singular causes may seem to be legitimate when describing events as they appear to an observer. But the world is a complex of myriad interrelated events simplified by an observer's selection. This raises the questions of both complexity and a subjective selection choice that is taking place. A simplified example of this is, did Jack fall off the ladder because he was too fat, inattentive, or for some other reason? We can see here that identifying what we call causes is much more obscure than supposed. These issues are exacerbated in the context of the mind, such as the free will debate and the causes of consciousness. In this light, the view that universal causation prevents something like free will is simplistic, because it ignores the forms of causality like complex causal fields and quantum mechanics. It overlooks the possibility of replacing causality with reasons for action, and it retains a simplistic notion of causality that is inadequate for mental events. Moreover, the holistic character of thought might not be captured by particular or holistic neural events. This is expressed in such theories as Donald Davidson's anomalous monism and David Wiggins' notion of cognitive underdetermination. The above considerations provide a critique of causality and a relation between both mental and physical objects. Hume enables us to break away from that relation as causality in order to consider other alternatives, such as complex causal fields, subjectively determined causal relations, and quantum mechanics. Uncaused quantum events and quantum entanglement add to those alternatives. These are alternative physical relations. Alternative mental relations are at the same time easier to find and more difficult to explain. In the context of the free will, even Aristotle replaced the idea of causality with reasons for action. Then there's Davidson's anomalous monism and Wiggins' cognitive underdetermination. And externalist theories of mind see the world as a necessary condition, but not as the cause of mind or consciousness. These are alternative kinds of relations to causality that evoke both an alternative description and a theory of mind. One alternative description to causality is that of presence to something, referenced by thinkers like Sartre, Samuel Alexander, Whitehead, and even Hume himself. Hume limited himself to distinguishing ideas as presence in fact or presence in power. As a mode of consciousness, Sartre defined knowledge or cognition as a presence to something. This is consistent with the widely accepted idea that consciousness is consciousness of something. Samuel Alexander's reference to presence referred to knowledge as compresence of a mind with an object. This was a metaphysical or even a mystical idea that involved direct realism with all those problems. So Alexander's compresence can only serve as an introductory or illustrative idea. Whitehead's slightly more respectable concept of prehension is the experiencing of past and present events. That is, every experience is constituted by relations to past events and a continuous flow throughout the universe. It helps to understand that Whitehead was a panpsychist, which finds consciousness in everything. This enables him to relate mental objects in the same way that physical objects relate. On this view, mental objects and physical objects relate internally and to each other in the same way. This means that, on this account, we could describe mental and physical relations in the same way, and a physical description of that relation could be the noted presence to something. But Whitehead proposes a dubious and hypothetical system of relations that requires development and evidence. For this reason, Whitehead's prehension and his system of relations can be no more than another introductory idea. And Sartre concurs when he says that the in itself, or physicality, can never by itself be presence. Yet the idea gains traction with the development of a related theory of mind. That is, given Hume's broader view of relations and a common description of relations as presence to something, then we can construct a complete interactionist account of mind from its very physical and neurological origins to its presence to the world as consciousness. And we could explain mind and consciousness from beginning to end with the same continuity of relations given as presence to something. Moreover, Hume's duplex of ideas and empirical facts inadvertently opens up a place for mind that he omits, and this could be compatible with Popper's three realms of matter, mind, and its abstract products. The development of such a complete and pluralistic account of mind must be undertaken elsewhere, as I have done. Yet we can nevertheless outline what such an account of mind as consciousness would look like. And like Whitehead, I can start an explanation at the beginning with matter, even before the emergence of life. The idea here is to show how the most simple and basic relations can undergo significant developments. For example, we can start with the relation between atoms or neurons or billiard balls which interact in many ways. For example, gravitationally, temporally, aerodynamically, or circumstantially, that need not be described as causal. But these are simple relations that don't produce even in infinitely low levels of consciousness. But some events are also complex, contain systems, have structure, feedback, and qualify as interactions. For example, engines, machines, computers with cause and effect in repetitious and continuous processes. And complexity increases with feedback loops, even in machines like internal combustion engines. Complexity increases in systems like quantum computers, plants, and single-life creatures like amoebas. These are integrated systems with complex interactions that register objects as presence to something. These interactions and registrations may mimic but don't yet amount to recognition or cognition. Further complexity includes insects, animals, apes, and humans with increasing consciousness. But complexity, or even organization, or certain constituents, are not sufficient to produce consciousness. The crucial factor isn't complexity, but relations of engagement and registration as presence to something. These relations simulate intentionality towards objects, that consciousness is conscious of something. Yet this simulation of intentionality eventually becomes consciousness of something. This provides a continuity of explanation from all causal interactions to consciousness. I have described this process in more detail in my podcast number 21 of series 8. My conclusion here, though, is to have explained the relevance of Leibniz and Hume's fork to both science and consciousness. To begin with, Leibniz's distinction and Hume's fork present different challenges to science. Leibniz offers a more objectivist foundation for causal science, but on a metaphysical foundation, and such a metaphysical foundation cannot be readily accepted by modern science. Hume, on the other hand, disengages from the scientific fact of causality with an epistemological fence. But both his neglect and his philosophical concerns leave the ontological question of causality unanswered. Yet Hume's subjectivist interpretation also leaves it open to implications of consciousness. That is, as above, alternative relations to causality opened up by Hume enable other relations offered by such as Sartre, Alexander, and Whitehead to allow the theoretical construction of an interactionist theory of mind from its physical origins to its conscious relations with the world. And in this discussion, we have incidentally cited a number of terms that extend our understanding of relations. First among these is Hume's distinction between relations of ideas and matters of fact. This was basic to his description of cause and effect as constant conjunctions. Hume's fork between ideas and facts also led to another distinction between a priori and a posteriori judgments, and that empirical a posteriori judgment can also be called synthetic, and that this leads to the analytic synthetic distinction and certain claims about knowledge. Namely, Descartes and Kant, for example, claim the existence of synthetic a priori knowledge. That is, we can actually know about the world and about ethics. I also ventured the will to value as a synthetic a priori, but I make this argument elsewhere. So let me have your comments and criticisms at the meeting or on websites like Zoom or meetup.com.